So good morning all of you, and today we are going to learn about the chapter name that is it's a surd. So basically 5 is a rational number. Okay, it's a rational number, but root 5 is not rational number. It may be the square root or the cube root of any number. Okay, if it may be the square root or cube root of any number which may be rational or irrational. Okay, rational or irrational. For example, for the root 4, square root of 4 is a how much? It's a 2. That is, it is a rational number. Okay, and the root of 5 is not a rational number. Fine. So today we are going to learn about the surd, that is our main topic. Okay, so in the surd, if what we say, if n is an integer greater than 1 and if a is a positive real number. Okay, it's a positive real number and a raised to the power nth root of a raised to the power nth root of a is how much? Is x. So we can write, we can written this in the form of like x to the power nth root is equal to how much? It's a, or we can say that here it's a nth number and here it's a is equal to how much? It's a x. Understand? So if a positive number in this question, if a positive rational number and nth root of a is x, root of a is how much? It's a x. And if x is n, and if x is an irrational number, then x is called a surd. Surd is the basically surd is an irrational root. Surd is an irrational root. As we know that here you can see that it is not a surd because the root 4 is equal to how much? It's a 2 and 2 is nothing but it's a rational number. Okay, and the root 5, whenever you find out the value of root 5 and then you didn't get any exact root, like root of 4 is equal to 2, so we didn't get the root 5 value exactly as like a 4. So that's why such type of the numbers we can say that it's a in the given, if a positive rational number and the nth root of a is x, and if the x is an irrational number, then x is called as a surd. So basically the root 5 we can say that it's a surd. So we'll see some example by which you are able to understand properly. For example, in a surd, so here it's a nth root, as we know that the symbol, okay, the symbol, this symbol is called the radical sign, is called a radical sign. And nth is the order of surd. And a is called radicand, and a is called so we'll see some example by which you are able to understand this. Let we take a is equal to how much, it's a 7, then n is equal to it's a 3, then we can say that, so in the root sign there is a 7 and here it's a, so we write this one in this way, and is a surd, is a surd. Why we call the surd? Because this number, okay, this number we can say that is an irrational number. So as similar, if we take the one more example, okay, let a is equal to how much, it's a 27, and n is equal to it's a 3, then we can write this question like this, here it's a 27 and here it's a 3. Now we get the answer in general, or we can say that then it is not a surd, because is not a surd, because if you know this in general, so you get the value 3 into 3 into 3, that is equal to, we get the value 3, and 3 is not an irrational number. Understand? Here it's a, we cannot find out the cube root of 7, or we didn't get any rational number when we solve this question. But in case of this question, you are able to get the value cube root of 27 is equal to how much, it's a 3, and 3 is not an irrational number, so therefore it is not a surd. Understand? We'll see the one more example by which you are able to understand. Again, if we take here, okay, here it's a 8 and here it's a it's a 4th, okay. So we write, when we solve this, okay, so if there is a 3, then we can say that 2 into 2 into 2, that means, and here we have the a is equal to how much, it's a 8, and n is equal to 4, so we are not able to find out the exact 4th root of the 8, okay. So therefore this number we didn't get their solution as an the rational number. Therefore we can say that the given is a surd. Because we didn't get the factors like this, okay, we didn't get the rational number at the end. Understand? Mostly this year we are going to study about surds of order 2 only. Okay, that means it may be the root 2, it's a root 7, then root 11, like this. Okay, and the surds of order 2, surds of order 2 is called quadratic surds. It's a quadratic surd. Now this is all about the surd. Now what we have to do, we have to study about the simplest form of the surd. It's a simplest form. Okay, it's the simplest form of the surd, so that is nothing but it's a root 48. How can we simplify it? So in general we can say that it's a 16 threes are, okay, 16 threes are 48. So the square root of the 16 is nothing but it's a 4 root 3. Understand, it is the simplest form of the surd. Again we can say that it's a if we 98, okay, 98 is here now. So 98 is equal to we can say that it's a 49, okay, 49 into 2. You know the square root of the 49, that is nothing but 7th root of 2. Understand? So in this way we are going to the simplest form of the surd we called as an simplest. It's a complex thing, we simplify it, that's why we called as an the simplest form of the surd. Now after that the similar or the like surds, it's a similar or like surds. As the name indicate, similar or the like surds. As we can say that here it's a square root of 2, then 4 upon 5 root 2, then we can say that minus 3 root 2 are the some like surds. So P and Q are the rational number, and inside there is a similar inside that particular in the surd the number is same, so that's why we can say that the like surds. Okay, we can say that it's a, see here if we take one example by which you are able to understand this. First of all, the root 45, okay, so we can say that here it's a 9 into 5, it's a 45. So then we can say that the square root of the 9 is nothing but it's a 3 root 5. As similar we take the root 80, okay, so 80 is nothing but it's a 16 into 5, therefore the 4 outside and the inside the, so then we can say that these are the like surds. Now in this definition, in the like surds, you can remember this. So in the simplest, so in the like surd, as we know that it is the simplest form of the surd. If the order of the surd and the radicand are equal, then the surds are similar or like surds. For example, as we know that it's a, for example, here it's a 5 and here it's a 2, again here it's a 5 and here it's a 5, then we can say that you can see here is the order, here it's order, that is the both are the square roots, okay, and inside that particular there is a radicand is also similar, then we can say that these surds, these two surds we called as an, it's a similar or the like surds. Understand? Now our next topic is nothing but it's a comparison of the surds. So basically we compare anything by the three symbols, which is this one and is equal to, okay. So then and only we can say that which is the bigger one, which is the smaller one, and which is the equal to that particular surd. So if we take the two positive real number, okay, if A and B are the two positive real numbers, and if A is less than the B, okay, and then we can say that then A into A, which is also smaller than B into A. For example, if we take here it's a 5 and the 6, then 5 square it's a 25, and then 5 into 6 that is the 30. So obviously this number will be greater than this one. So as similar, for example, if here we take again A into A, that is nothing but it's a square, which is the less than AB. That means we have to give the equation number 1. As similar, if we take the AB here, what we have to do in the next step, in the first case we multiply by the A on both sides. Now in the second case, what we have to do, we have to multiply this term by the both number. Here it's a into B, then the next one it should be the B into B, that is the B square, okay. So therefore we can say that AB, which is also less than the B square, it's a equation number 2, okay. So as similar, we know that A square, which is the A square which is less than the B square, okay, here it's a B, you can see here, that means in this series from 1 and 2, from 1 and 2, again you can simplify this by, we can say that it's a square, then it's a AB is here middle, and then here it's a B square, Okay, so ultimately you can see, compare this term, you can find out this one. Understand? But if, for example, but if a which is a greater than b, okay, a is greater than the b, then what happen? A into a, it becomes a square. Okay, it's a square which is the greater than ab. Is it right? For example, here it's a 6 and here it's a 5. So 6 square is the 36, 5 square it's a 25. So obviously this number it is the greater than. Along with, for example, 6 into 6, 36. Okay, and 6 into 5. Okay, it becomes 30. Ultimately this number is greater than this one. Okay, and if, for example, and if a equals to b, then we can say that a square which is equal to the b square. Understand? Hence, if a is less than b, then a square which is the less than b square. So hence a and b, hence a and b are the both are the real numbers. Okay, real numbers. So maybe it may be rational or surds. So by using this property, we are going to just take that particular the surd which is the greater or which is the smaller one. Now we'll see some example by which you are able to understand that which surd is greater one and which is the smaller one. For example, if you take 6 root of 2, then the another one it should be the 5 root of 5. Okay, now how can we understand that which surd is a, or which of the particular from these two numbers which is the greater one or which is the smaller one? So what we have to do in general, here it's a 6 inside, so we can write this one as an the 36. Here it's a product, that means we have to multiply this one, it's a root, and just at the middle of this, here the 5 we can write here, it's a root 25, again it's a root 5. Okay, so as we know that what we have to do, both are the square root, so that's why we write here as an the 36 into 2. Here it's a one blank, and inside this, here it's a 25 into 5, again the 36. Okay, 36 into 2 is nothing but it's a 72, and we have this blank space for the symbol, and again here it's a 25, 5 is nothing but it's a 125. So as we know that here it's a 72, so we can write this when we find out that so therefore when we find out this one, root 125 and root 75, that number, when we squaring on this both two number, the 72 which is the smaller than the 125. Okay, so therefore we can say that the 6 root 2 which is the smaller than the 5 root of 5. We'll see the one more example by which you are understand this. We take here 8 root 3 and the next one, so we take this the 8 root 3 and again the root 192. Okay, so we can write here it's directly 8 8 how much, it's a 64. Okay, here it's the 64 into, directly we write here 3, and here we have the blank space here. Here it's a 192. Now you can again find out. 4 3s are 12, carry 1, 6 3s are 18, plus 1 it's a 92, and here it's a root 192. So we can say that having the same number, so therefore we can say that it's a 8 root of 3, which is the equal to the, how much? It's a root of 192. Understand? So in this way we are going to compare the given surds or the rational numbers. Again, for your better understanding, we can take one more example by which we'll take the 7 root 2. Okay, it's a 7 root 2, then it's a 5 root 3. 5 root 3. Now what we have to do as similar, so we write here it's a 49 into root 2. We have the blank space for the comparison, so we can write here it's a 25 into root 3. Again here it's a 49 into 2. Here it's a 25 into 3. So 49 into 2 is nothing but it's a 98. Again here it's a 75. So which is the, when we squaring on both sides, so we get the value. Okay, but 98, which is the greater than the 75. So therefore we can say that this root, okay, 7 root of 2, which is the greater than the 5 root 3. All of you understand how we compare the given the surds with other surds? That is the all about. Now we'll see, our next topic is nothing but it's a the operation on like surds. On the like surds, as we know that the like surds inside that particular the quadratic surd, you can see here inside that particular it should be the power. Okay, both the surds should be have the square root, and inside that the radiant should be equal. So for example, we are going to learn about the first one. It's addition of the surds. Okay, addition of surds. Okay, so first of all the question number 1 is nothing but it's a simplify. Okay, we have to simplify the given question, and the question is that the 7 root of 3 plus 29 root 3. Okay, so what we have to do in general, from these two number, okay, we have these two number, what we have to do, the root 3 is common, so we can take here outside, then the inside the 7 plus 29. Understand? So root 3 is here, it's a 36. So we can write the given question here, it's a 36 root 3. Understand? It is the, we simplify the given one. Then the next one, it should be the subtraction. Okay, simplify the surds, that is a, it's a 7 root 3 minus 29 root 3. As similar, what we have to do in the given surd, the root 3 is common, so we'll take outside that bracket, and the remaining is that 7 minus 29. So here it's a root 3. As we know that the 7 is smaller and this is the bigger one, so we take the minus sign here. Here it's a 22. So we can write here it's a minus 22 root 3. Is it right? Again we can simplify same question or any other, we'll take the any other question. So simplify, then what we have to do, simplify the given question. It's a 7 root 3 minus 29 root 3. Okay, again what we have to do here also same, we have to take the 3 root 3 outside, and 7 it's a minus 20. That's a simple one, it's a minus 22 root 3. Then the next one, it should be the 8 root 5. Okay, plus then it's a root 20 plus here it's a root 125. So we can do one thing, okay, in this question we have the 8 root 5 as right it is, then plus here we can write it's a 4 5 then, okay, plus here it's a 25 5 is a, so we can simplify 8 root 5 plus here it's a 2 outside that particular square root, remaining is 5, plus here it's a 25 square root, it should be the 5, and inside the only 5 is remaining. Now you can do this, it's a root 5 outside, the remaining is that 8 plus 2 plus 5. Understand? Here it's a 10 and it's a 15 root 5. It is the simplify of the given surds. Understand? Now our next topic is the multiplication of the surd. Okay, it's a multiplication of surds. Multiplication of surds. The simplify the question number 1. It's a root 7 into root 42. Is it right? So what we have to do? We have to answer this. It's a root 7 into, we can say that root 7 it's a root 45 is there. Okay, so when we calculate it directly we can say that it's a 7 into 42. Is it right? So then we solve this, we get the value, that is 7 into 7 into 6. So here, so we can directly, 7 7 is a 49 and square root of 49 is nothing but 7 root of 6. Understand? It's a multiplication. Now the fourth one, it's a divide the surds. It's a divide the surd. So here what we have to do, we have to take the first one, it should be the root of, it's a 125 divide root 5. Okay, so here is also same thing we are doing. Here it's a root 125 upon root 5. So we can write here it's a 25 into 5 upon root 5. Again here it's a square root of the 5 should be outside, and the remaining is that root 5. Now this term will be cancelled, the remaining one it's a 5. So we can say that the 5 is an rational number. 5 is a rational number. Our next topic is the rationalizing the surds. Okay, that is nothing but rationalizing is nothing but what we have to do, if a product, okay, if a product of two surds is become a rational number, product of two surds, product of two surds is a rational number. then each surds is called rationalizing factor. For example, if okay, for example, if we want to rationalize the root 2, then what we have to do, root 2 is multiplied by root 2, then we get root 2 into root 2, it becomes how much? It's a, so we solve this 2 into 2, it becomes root 4. As we know that the square root of the 4 is nothing but it's a 2, that is the two is a rational number. Okay, so root 2 is the rationalizing factor. Of root 2. Understand? For example, if we see one more example, so root 2 is here, okay, into root how much? It's a root 8. Then you can see that when we solve this question, we get the answer. It's a 2 into 18. 8 is equal to how much? It's a root 16. That means we can say that when we find out the root 16 is equal to is nothing but it's a 4. Okay, so therefore we can say that because of this the root 2, this root 2 is a rationalizing factor of root 8. Now if you want to, we see one more example. Okay, find the rationalizing, we take find rationalizing factor of what we take a quotient that is a square root of the 27. Okay, now we have to find out the rationalizing factor of the 27. So how we do this? In the solution you can see that it's a root 27. So we can write this root 27 into the 9 into root, okay, 9 into 3. Now we can do one thing, here it's a root 9, here it's a root 3. So as we know that the square root of the 9 is nothing but it's a 3. Again root 3 is remaining. Now what we have to do, when we multiply, okay, multiply this number 3 root 3 by root 3, then we get root 3 into root 3, it becomes 3, then we'll get the answer 9. So therefore we can say that it's a root 3 is a rationalizing, okay, it's a rationalizing factor. Understand? Root 3 is the rationalizing factor of root 27. That means by just multiply by root 3 is the given number, then we'll get the answer, that is a 9, and 9 is nothing but it's a rational number. Okay, that is about the rationalizing. Our next topic is that the rationalizing the denominator. Okay, it's a rationalizing it's a denominator. Okay, rationalizing denominator. So in general, what we have to do, we take one example. Okay, it may be it's a 3 upon 2 root 7. Now what is our topic? It's a rationalizing the denominator. So in the denominator you can see that there is a the root 7. Okay, so what we have to do, we have to take in here it's a root 7. So how we can remove this root 7? We have to multiply by root 7 on the numerator as well as on the denominator. So then we'll get the answer, just multiply, it becomes a 3 root 7. Okay, as similar here it's a 2 root 7 into root 7. Now here it's a 3 root 7 upon root 7 into root 7 into root 7, then we'll get the answer, it's a 3 root 7 upon, here it's a root 7, 2 into root 7 into root 7 is nothing but it's a 7. So we'll get 3 root 7, okay, upon 7 to the 14. You can see that at the denominator there is no any irrational number. Okay, is there any surds? So on the only numerator you can see that. So in this way we rationalize the denominator. Understand? As similar, we'll see one more example by which you are able to understand the rationalize the denominator. That is nothing but it's a 1 upon root 5. Okay, in the solution what we have to do, as similar we have to write down as it is, then is equal to 1 upon root 5 into root 5 upon root 5. Okay, so you can see that 1 into root 5 it becomes root 5 and the root 5 into root 5. Again on the numerator there is a root 5 upon, you can see that it's a 5 into 5. So it becomes, so root 5 upon root 25. Then what is remaining? It's a root 5 upon the square root of the 25 is nothing but 5. In this way we it becomes 5. Here it's a, so that's why this way we have to rationalize the denominator.